Thank you all for joining. Welcome to the stream. This is Satyajit Pattnaik. Today we are getting into the third part of machine learning. I hope everybody is still joining. So let's give like 2 or 3 more minutes for everybody to um, settle up. In the meanwhile, can everybody give me a confirmation if my voice is audible or not? To be very honest, I just came back from somewhere and I'm in a super rush. So I am not sure if everything is fine. You're able to see my screen, you're able to hear my voice. Just give me a confirmation and then we will quickly get started with the third session. Hello, everybody. Hello, Bashir. It's very clear. Thank you. Okay, without wasting our time, let's quickly get started with the third session of machine learning. Just quickly giving a brief recap for people who have not joined the previous classes. This is a machine learning live class that we have planned, and I'm planning to go live for the next 3 more classes. So we are planning for a total 6 classes for machine learning, which is around 12 hours. This is our third class. So far, we have already covered the basics of machine learning, types of machine learning, and a lot of classification algorithms. Today, we shall be jumping into our last algorithm, which is support vector machines. And then going forward, we'll talk about classification metrics, regression, and various other things. That is what is today's agenda. I'm trying to finish regression. Will not focus much on regression because there are many more important topics. The most important topic is going to be classification, which is majorly covered. However, once we talk about the problems in classification, once we go through a project, you will have a better understanding. Okay. The second most important thing in machine learning is time series analysis and forecasting. I already have a 8 hours videos on time series analysis and forecasting. I will be giving lectures on time series analysis and forecasting, but the lecture will be just for 2 hours. Okay. But in case you are interested in learning time series in depth, I can also share you my time series course for free. So just let me know in the comment section after this live video is over, and I'll provide you the coupon codes for time series analysis and forecasting. Okay. Let's get started. Let's not waste our time. So far we have already covered various classification algorithms, right? If I go back to my Miro board, yes, these were the agenda of today's class, which was told in the previous class, right? So let's get started with support vector machines. Now, support vector machines, very important algorithm. um, Let me just write it down. Support vector machines. Okay. The mathematics behind support vector machines is somehow not very clear on multiple YouTube videos. If you go and search, there are various AI and machine learning gurus already on internet. But if you go and try to understand support vector machines, most of the videos do not explain you in a layman's term. So my goal is going to be explain you in a layman's term so that you understand the algorithm. Implementation part is definitely easy, right? So what exactly is a support vector machine model? Try to understand that. Support vector machine model is basically a representation of different classes in a hyperplane in multi-dimensional space. Okay, I'll not waste my time here on this PPT. I'll probably go ahead and explain you what is support vector machines. So let's say I'm talking about a classification problem. Can I zoom in a little bit? Okay, this looks good. Okay, so let's say we are talking about a classification problem. Okay, let's say we are talking about breast cancer prediction or any kind of problem. Okay, so there are, let's say, 2 classes. We'll talk about breast cancer prediction. Okay, breast cancer prediction. Now the data set that you have here is, you have patient's information, right? I hope everybody has the breast cancer prediction data set that was shared in the last class. In case you have not received it, you can probably go to my GitHub account, and here you should be able to download the code. I will be maintaining this repository for all the machine learning classes. So whatever code data that I will be using in the class, I will push it here. So you need to download the code or fork it. If you are not new to GitHub, you know how GitHub works, you can easily fork it. If you are complete beginner in GitHub, simply you can just go ahead and download it. Okay, that is what you can do. But as a respect of the classes of me, try to give me stars, because stars are very important. Okay, anyways, this is the data set. Now this data set is basically the breast cancer prediction data set, right? You have multiple information. Based on that, we know whether this patient is cancerous or not. M is cancerous, B is non-cancerous. Okay, now basically you have cancerous data and non-cancerous data. So you have two classes. Imagine imagine you are trying to represent the classes in a graphical format. Let's say I will draw a two-dimensional graph. Okay, let me just rub this off. Yeah, let's say you have class 1, class 1, class 1, class 1, class 1, class 1, and this is your class 2, 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 class 2. Okay, now just repeating once again, this is just an example. Okay, that's why I have like this. In real scenarios, first of all, you will not be able to visualize your data. Why? Because in your real scenario, let's say I go to the data set, how many features are there? There are hundreds of features. In this case, there are 30 features, right? So can you draw a 30 dimensional space? Not possible, right? Human eyes are only restricted to two dimensional and three dimensional, right? So 30 dimensions are not possible. That's why I'm only taking two dimensions. Imagine this as x1, this as x2. X1 could be anything. Imagine x1 is radius mean and x2 is texture mean. Now based on radius mean and texture mean, let's say I have different data sets, right? Data points, and I have visually shown these data points. Understood? Now, in this case, how many lines are possible to divide the data properly? There could be millions of lines, right? There could be line number L1, there could be L2, similarly, there could be L3, there could be millions of lines, right? That is basically separating the two classes. Our task in support vector machines is to identify the best line that basically divides the classes into two different sections. Okay, in two-dimensional space, this is how it is done. When it comes to three-dimensional space, three-dimensional space cannot be drawn on screen, just visualize it. Okay, let's say you have three dimensions. One is your x1, one is your x2. Let's say the third dimension is towards you. You are looking at the screen, it's towards you, right? So there are three dimensions. Now in three-dimensional space, your data points could be like this, and your second class could be like this. Now here you can potentially have a hyperplane that is basically dividing the data. Okay, you must be thinking that in all the cases, do we have something like this? The classes are easily distinguishable? No, it's not the case. There could be scenarios where classes are not properly divided into two segments, but your ultimate goal is to find the best line that basically divides these data points. If it is not possible for you to have the separation in a particular dimension, you can potentially go to a n dimensional space and try to separate the data points. That is what support vector machines are all about. Okay, now there will be doubts for sure, so keep your doubts with you and feel free to ask me after I am done with the support vector machines part. Okay, let me just redraw this again. Let's say I have few data points and this is class 2. Let's say this is your line 1 and this is your line 2. There are millions of lines possible, right? I'm just drawing two lines. Okay, now in this case, if somebody asks you which line is better, it's very difficult to say, right? But I'll go with L1 because L1 has a clean distinction. They are possibly divided very well. Well, it's dicey. You can also call L2, but with human eyes, I think L1 is better. Okay, now practically, I mean, mathematically and statistically, support vector machines works on the principles something like finding the distances between all the data points so that we can find the d value. So let's say for line 1, what we can do is we can first identify that particular data point. Let's say this is your cancerous data, this is your non cancerous data. Okay, from your cancerous data, you need to find that particular data point which is closest to the non cancerous group. Other way around, you need to find that non cancerous patient which is closer to the cancer group, right? So, this basically means that patient who has the characteristics of non cancerous, but the patient is cancerous. So, maybe I would consider this data point, or maybe let's say there is another data point here which is closer to this group, so this becomes by support vector from class 1. From class 2, let's say I have a data point here, so this becomes my support vector from class 2. So these are called as support vectors. Okay, so our main goal is to identify that particular data point from class 1 which is likely to be class 2, and from class 2 which is likely to be class 1. And from there what you need to do is you need to identify the distance. Now let's say this distance is, let's say, d1, and this distance, you need to identify the distances. After you identify the distances, you need to finalize which line is closer to the data points, and based on that you can take your final call on which line is better. Similarly, if you move to a three-dimensional space, you need to find the hyperplane, or you can call it as a plane. In three dimension we call it as plane, right? Moving from three dimensional to four dimension or five dimension or n dimension, it is called as hyperplane. So two dimension space, it is called as line. Three dimensional space, it is called as plane, and anything more than that, it is called as hyperplane. Okay, now what is the algorithm, or what is the pseudo code to identify the best possible line? The pseudo code is very simple. First of all, let's say you have few data points, right? Let's say randomly select a line. Okay, now let's say line 1, right? What you need to do is you need to parallelly go both ways. So let's say if you go both ways parallelly, right, you have to go both ways parallelly towards class 1 and towards class 2, so that you reach the first point of each class, right? Let's say here you reach the first point from class 1, and here you reach the first point of class 2. Now what is margin? There is a concept called as margin. This is called as margin d. Okay, Similarly, I'll try to replicate this piece of thing. Let's say I have one data point, 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 and let's say we have here, 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 here. Let's say I'm drawing another line L2. Okay, we have to do the same thing. You have to parallelly go in both the directions. Let's say now what is the margin here? Let's say this is D1, this is D2. Okay, now if the margin D1, let's say D1 is greater, the margin is greater, that means they have the maximum separation. Let's say D1 is greater than D2. For example, let's say D1 is greater than D2. What does that mean? Is L1 better or is L2 better? What do you think? Can you write it down in the chat box? I have two scenarios, right? Class 1, class 2, class 1, class 2. I have just drawn two different lines. Now our goal is to identify the best line. Looking at the graph, I think D1 is greater than D2, right? Because this distance is smaller, this distance is larger. Now, give it a guess. Which line do you think is the best line here? Is it line 1 or is it line 2? I'll wait. Okay, feel free to answer. I'm completely fine if you give a wrong answer. So do not hesitate to answer, okay? Which line is better, L1 or L2? I'm not talking about D1 and D2. I'm talking about L1 and L2. D1 is better than D2. That is for sure, right? Yes, Gayatri is telling D2 is having closest. Fine. What do you think? Okay, some people is Vinith is answering L1. Narottam is answering L2. Nilesh is answering L2. Okay, I'll tell you which line is better. In this case, sorry, did I say here the lowest distance is better? No, if I said that, I'll take my words back. I'm wrong. Uh, line 1 is better. Why? The reason is very simple. They have the maximum separation. Maximum separation, which means they are able to distinguish between both the classes in the maximum possible distance way. So this is how the flow happens. Like L1 and L2, there could be millions of lines. For millions of lines, there could be millions of distances. Whichever distance is the largest distance, let's say D5 is the largest, then line 5 becomes the best line. Okay. Now, in this case, among L1 and L2, as L1 is better of maximum separation, what are going to be your support vectors? This is your support vector and this is your support vector. Okay, so that is why it is called as support vector machines, because this is based on the principles of support vectors. Our lecture is not yet over. Now comes the most important part. Mathematically, if somebody asks you, can you write me the equation for support vector machines? The equation of support vector machines is very simple. It is W transpose X plus W0 is equals to 0. Okay, how the hell did we get this? I will explain you the mathematical explanation. Okay, so do not worry about this part, but try to remember this is the generalized formula. Generalized formula of L1. Okay, now how did we get this formula? This is the most important part where you can do your own check. Go to the YouTube, try to search different support vector machines videos. 8 out of 10 videos they will not explain you these things. Okay, so, and this is very important, right? Mathematics is important. Practicals, anyways, you can go ahead and implement sklearn support vector machine, and you will be able to build a model. But who will explain you the underlined mathematics, right? How these lines are created, how the separation happens, how the formula is generated. Now let's try to get that answer. Okay. Yes, Karthik. Which one has largest distance? They are the best. Okay. Now let me redraw this. Okay. In two-dimensional space, we call it as a line. Okay. I already explained you. In three-dimensional space, we call it as a plane. Right. Anything beyond that, we call it as a hyperplane. Okay. Now, what is the formula of a line? Can somebody tell me in the chat box? It's very simple. Sorry, I did not wait for your answers because there is a delay, right? By the time I am telling you and by the time you are listening, there is a delay because I'm using this online tool called as StreamYard. So there is a few seconds delay. So, anyways, everybody knows about the equation of line. What is m? M is the slope. What is c? C is the intercept. Right? Now, if I take y is equals to 2x plus 2. So, how will the line look like? Let's say I will draw a small table. For x0, y is 2. For x1, y is 4. For x2, y is 6. Right? So, if I draw the line, my line looks like this. x0, y is 2. x1, y is 4. X2, y is 6. So, this becomes y is equals to 2x plus 2. Now, what is the distance? This distance is 2, right? So that is the, I think the example is bad. We should not take 2x plus 2. Instead, I will take a different m and different c. Just give me 1 second. Let me just change the equation. Let's say I will take 2x plus 3. Okay, now it is clear. So for x equals to 0, y is 3. For x equals to 1, y is 5. For x equals to minus 1, y is 1. And so on, right? For x equals to 2, y is 7. And so on. Now, if I draw this graph, for x0, let's say y is 1, 2, 3, 4, 5, 6, 7, 8, right? So, this is the first data point, right? Second data point will be somewhere here, right? Third data point is 1 minus 1. So let's say for x minus 1, y is 1. So somewhere here, right? So this is how the line will be, right? What is the formula of this line? Y is equals to 2x plus 3. Okay. What is the distance? This distance is 3, right? That is the intercept. What is slope? Slope is basically like this. If you consider this as delta y, consider this as delta x. So the slope is basically delta y by delta x. In this case, it is 2. Okay, simple mathematics. I'll move on. My equation of line is y is equals to mx plus c. Can I write it this way? Ax plus by plus c is equals to 0. Can I write it this way? Yes, I can write it. You can generally write this equation like this. Okay. Now, if I take one step ahead, so let me do this here itself. If I take one step ahead, what will be y? Y will be minus ax minus c divided by b. Okay. I will take another step. Y is equals to minus a by bx minus c by b. So you can also write it this way, right? Simple. This is a generalized formula. Okay, this is your slope and this is your intercept. Okay. Now, if I move forward in two dimensional space, initially I was taking x and y, right? Instead, I'm taking x1 and x2. Can I write it like this? Ax1 plus bx2 plus c is equals to 0? Yes, I can write it down. Right. Now, if I generalize this, I will write it down as w1x1 plus w2x2 plus w0 is equals to 0. Okay. This is a more generalized equation of line. I will write it down here. More generalized equation of line. Anywhere you are not able to understand, ask me. Okay. But I'm pretty much sure it is clear. I'm going very slow. I'm explaining it very nicely. That's what I'm assuming. But in case you're not able to understand, just let me know. Okay. Fine. Cool. This is, let's say I will write it down as equation 1. Now, if I move from two-dimensional space to three-dimensional space, can I write my equation like this? W1x1 plus W2x2 plus W3x3 plus W0 is equals to 0. Yes, I can write it down. If I move from three-dimensional space to a n-dimensional space, can I write it this way? Dot 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 Wnxn is equals to 0. I can write it down. Now, if I have to generalize it again, can I write it like this? This is nothing but the dot product, right? So W dot product of X plus W0 is nothing but 0. This is not multiplication, this is dot product. Okay. Mathematics, if you don't understand dot product, let me know. I will explain you dot product, but not in this class. Okay. Because I have an agenda today to finish. Let's say at the end of the class, remind me if you need me to explain you dot product, I will explain. Okay. Maybe I'll also explain dot product here. See if you are able to understand. In case you are still not able to understand, we'll see. Okay. So do not worry. Dot product is nothing but, let's say you have two different matrix, right? Let's say a 2 cross 2 matrix and a 2 cross 2 matrix. If you multiply both, your output will be a 2 cross 2 matrix, right? So this is a dot product, vector dot product, right? Something like that. Now we can also write it this way, right? W1 dot 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 Wn x1 dot 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 xn. Now this is your row vector and this is your column vector. Okay. Now this is nothing but WT. Why? What is T? T is nothing but transpose. If you write it down W as this, what will be the transpose of this? The transpose of this will be like this, right? Vector transpose, I think everybody should know. If you don't know, simple explanation is pandas transpose. Inside pandas library, pandas transpose. What is transpose? Transpose means your rows becomes columns, columns becomes rows, right? In pandas also we have transpose. So let's say you take an example, column 1 and column 2. If you take the transpose, your column becomes rows and the rows becomes columns. That is transpose, right? That's why I'm writing this as W transpose, right? Now can I write it like this? This is nothing but W transpose multiplied with x, or let's say I will write it down as xn, or I'll let it write it down as x. Okay, x vector. X vector is nothing but x1 till xn plus w0 is nothing but 0. That's why I told you this is the generalized formula, right? Now this is a formula for any kind of dimension. So you go to any dimension, the equation remains the same. Okay. Now we'll talk about what if my WTX is 0. What does that mean? First of all, that means my W0 is 0. uh, Basically, if I write my equation like this, right, that means my this part is 0, right? Now if this part is 0, what does that mean? That means the line is basically going through the origin. That's why it is 0, right? So this is a more generalized formula. So if interviewers ask you, you can either write this formula or this formula, or even if you write this formula, then also it is fine, no problem. Okay. Now WTX is nothing but W multiplied with X, right? So let's say if I write down in in the format of vectors, it is W vector multiplied with X vector multiplied with the cos theta value. That means this is theta. Okay. Now if my this part is 0, what does that mean? That means either this is 0 or this is 0 or this is 0. Now, assuming these two cannot be 0, assuming cos theta is 0. If cos theta is 0, what will be theta? Theta will be 90 degrees. Okay. So, this is the generalized formula of finding the best line when it comes to any kind of dimensions. It is very difficult to go through 3D and 4D space or even more dimensions. That's why I took an example of 2 dimensions. Okay. Now, we'll go through the practicals. Practicals is very simple. We already have the collab ready for our breast cancer prediction thing. Where is the breast cancer prediction thing? This one, right? Let's try to implement. Yeah, this one. Okay. Now I am going to take the data again. Might not be there on my Google Colab by default. Data 2. Done. I will simply run these codes. So we had already done this part, right? We had done this till naive base. So today we will jump into the SVM part. So let's try to implement SVM in the code. Now SVM basically has now if you go and Google it out, SVM inside sklearn library there is something called as SVC. This is nothing but SVM, support vector machines. Okay, this is for support vector classification. It is called as SVC. So we will be using this. So sklearn.svm, from sklearn.svm import SVC. That's it. Oh, sorry, I changed it here. My bad. My bad. Wait. Let me first copy this piece of code. Copy, and copy. And then after copying, here I will change this library from naive base to SVM. I will take my SVC. I will create my SVC, model SVC, YPRED SVC, model SVC, YPRED SVC, done. Okay, so let's run this piece of code. Oh my god, so SVC is giving us the best result so far, 97%. Now if you ask me, sir, can you draw the line? I cannot draw. Why? Because there are so many features, right? So there are more than 30 features. So 30 dimensional space is not possible. So you cannot visualize it, but mathematically, whatever I explained, that is happening inside the support vector machines. Okay, so that is the advantage of support vector machines. Okay, so moving on, logistic regression is something I'll quickly cover when we jump into regression part. Okay, so I'll cover that. Next topic is classification metrics. Okay, now the first metrics is log loss. Um, Log loss is something that we usually don't use a lot. I mean, again, this is a personal call. I personally don't use it a lot. So, and again, I'll try to skip this part. Okay, we'll focus on the most important ones. So there are multiple metrics. First of all, try to understand what is metric. Metric is nothing but something. A metric is that concept which tells you whether your model is built well or not. Okay, so in simple terms, if you ask me, how do we get to know whether the model is performing well or not? So the simplest thing is accuracy, right? So let's say you have 1,000 records. Out of them, let's say 200 records are uh, testing data and 800 records are training data. So you go ahead, you are building the model, let's say machine learning model 1. Now on top of these 200 records, you are doing some predictions. You already have the existing data for these 200 records, which is y test. You are comparing them, right? Let's say out of 200, your model has predicted 160 properly. So if you divide this by 200 and multiply, that becomes 80. So your model's accuracy is 80%, right? Similarly, your models, similar to accuracy, there are various other metrics. We usually don't go for accuracy. Why? The reason is accuracy is a very bad metric. I'll give you an example, okay? The example is Bashir YW. That's a generalized formula. That's it. It's a constant value. So as it is relevant to x1, I took it as w1, for x2 w2, x3 w3. Right? Same for multiple linear regression also, right? When we will be using multiple features, we will be having multiple slopes, right? So I'm generalizing and writing them as w1, w2, and w3. Okay. So why accuracy is not good? Try to understand this thing. Imagine you are doing a fraud detection model. Okay. You have, again, I'll give a simple example. You have 1,000 records. Out of these 1,000 records, only 5 records are fraudulent records. Okay, now you divided the data into training and testing. By God's grace, let's say here we have 800 records, here you have 200. Somehow out of these 5 records, 4 records were a part of the training data and only 1 record was part of the testing data. Okay, so you built a model. In fact, you built a model where your model is going to predict, let's say the model is predicting all the records as not fraudulent. So the model will predict how many records? 200 records. And all the records the model is predicting as not fraud, not fraud, not fraud. But if you go to the actual data, all of them are not fraud except one, right? So one is fraud, others are not fraud. Dot 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 dot. Now, how many records is my machine learning model able to identify? Machine learning is able to identify 199 properly, right? Now what will be the accuracy here? 99.5. Very good accuracy, right? But it's not good, right? Accuracy is not a good metrics here, because instead of creating a machine learning code, why can't I just write a simple Python code for every record? Just make, just do not fraud, just predict it as not fraud. Why do you need machine learning for this? Your Python, simple Python code will also achieve 99.9, 99.5% accuracy, right? So that is why when it comes to data set like this type of data set is called as imbalanced data set. And in imbalanced data sets, accuracy is treated as cursed. Accuracy is cursed. That's why we don't use accuracy as one of the metrics. If your data is balanced, then accuracy can be used, no problem. Now, if accuracy is not used, which one is used? What metrics do we have? So let's try to go through some of the important classification metrics. The first important classification metrics is, I'll go back to the PPT, which is called as confusion matrix. Now, confusion matrix itself is very confusing, but I will try to explain you so that one time if you pay attention, your you will never be confused with confusion matrix. Confusion matrix is very simple. Confusion matrix is basically, let's say I have actual and I have predicted. One second. I have a data. How do we know if the data is balanced or not? So if the data is a classification data, you know your Y label. So just simply take the data frame, go to that Y label column, and just do value counts. When you do that, you will be able to see the distribution. If it is around 50-50 or 40-60, then it is fine. It is can be considered as balanced data. But if it is like 80-20 or 90-10, something like that, then it is not balanced. Okay. So again, to make imbalanced data balanced, again there are multiple techniques like smart NN, smart TNN, Adasin. So again, these are very advanced topics. Again, in 12 hours, I barely will be able to go through them. But if you check the web or check YouTube, you should be able to get some videos and try it out. Okay, I'll not be able to go through them. Sorry, there was a network glitch. I hope everybody is able to hear me. Sorry, just give me a confirmation. My network got reset. Actually, I mean, for 5 seconds I was offline. Now it is fine. Hello, hello, mic check, mic check. Are you able to hear me now? Now it's good, right? Yes. Yeah. For 5 seconds there, my network went down. I don't know why. Anyways, coming back to confusion matrix, guys, I'll be a little bit fast because we don't have time today. I have to finish regression so that in the next two classes or three classes, I should be able to finish ML to a good extent. Obviously, end to end machine learning, I can teach for 100 hours, but I just I'm trying to compress everything in 12 hours, right? So let's see how much we can cover. So confusion matrix is basically a matrix between actual and predicted. Okay, and this is especially for the testing data. Okay, imagine you have 1,000 records. You divide your data into training and test. For your testing data, you already have the actual data, right? Now your model is giving you the predicted data, and then you have to take and put the numbers into the confusion matrix. Okay, so I'll go back here. 0 1 0 1. Now actual 0, predicted 0, that basically means if you are taking the breast cancer prediction use case, how many of them are actually non cancerous, and the model has also predicted them as non cancerous. Okay, that is called as actual 0 and predicted 0, and that is called as true negative. That means truly predicted as negative. You can write it down as TN. Okay, this one, this window is actually it is cancerous, predicted also cancerous. That is called as truly predicted as positives. You can write it down as TP. Okay, this box, this box, this box is actual 1 but predicted 0. That means actually the patient is cancerous, but your model is predicting them as non cancerous. Now this is a very very vital scenario in healthcare industry. You should definitely make them low, as low as possible. Okay, um I'm back. um Sorry guys, this is expected, cannot really help. I'm just repeating what I said. I'm getting disconnected. I don't know why. Is it audible now? Right? Something. My internet seems to be a problematic today. Um, I'm having some network issues. I don't know. If this continues, we'll probably have to stop it here because continuously my internet is going off and coming on, so it's difficult. Now it seems to be stable. Let's wait for 2 more minutes. If the internet is stable, then I'll continue. Is my voice audible right now? Is my voice audible now? Sorry. Sorry for the network glitch. Yeah, cool. Let's continue. If my Wi-Fi shows me a problem again, we'll have to stop this class here itself. Anyways, now I'm talking about this particular block. Okay, this particular block is actually the person is cancerous, but your model is predicting them as non-cancerous, which is very bad, right? Because the patient is actually problematic, but your model is telling no, she's fine. So in healthcare industry, this is the most important thing. You should always get this number as low as possible. This is called as falsely predicted as negative. So I'll write it down as FN. Okay. And the last box is actually it is 0 but predicted as 1. That means actually the patient is fine, non cancerous, but you are predicting it as cancerous. Now this is somehow fine. When it comes to healthcare industry, it is somehow fine, right? So this is called as falsely predicted as falsely predicted as positive. Okay, that's how you can remember. If you draw this graph, actual 0 1 predicted 0 1, you can actually identify 0 0 means false, truly predicted as negative, 1 1 truly predicted as positive, actual 1 predicted 0, that means predicted is wrong, right? Predicted as negative, so falsely predicted as negative, FN. Actual 0 predicted 1 is FP. Okay. Yeah. So, Karthik, that's a very good question about covering principal component analysis. So, principal component analysis right now is not in my agenda, but I am trying my best. I will be able to include it because I know PCA and LDA are very important topics. So, potentially, it will be in my agenda. Okay. I still, I'll be very honest with you, I still don't have the exact visibility on the next three classes, but I'm assuming that I will be able to complete the regression part today. Tomorrow, we will be completing the clustering part. So the last two classes, we can have time series analysis and forecasting. And then last class, we will focus more on this thing, hyperparameter optimization, and we will focus more on the projects part. This is what my plan is. This is a very rough plan. I know PCA LD is very important, but what you can do is you can potentially go to my channel, um, and if you go to the playlist, I have created a new playlist for this end-to-end machine learning, right? If you go, part 1 is here, part 2 is here, today's class is part 3, right? So part 3 will also be visible here. If you scroll down, you will see a bunch of videos for PCA, mathematics behind PCA, LDA, and use case. These 5 videos, okay, these 5 videos can actually help you. So just in case I will not be able to go through them in the class, I will be going through, but not very in depth. So in depth, if you want, you can see here. You can see almost 1 hour 7 minutes, almost 2 hours videos only on PCA and these kind of things. Okay, so you can go through them. Coming back, so this is how confusion matrix is. Okay, so from confusion matrix, you also know about all these jargons, right? TN, FN, TP, and FP. Now, false positive is type 1 error. This is called as type 1 error. This is called as type 2 error. And always remember, type 2 error is the most critical in healthcare industry. Okay. Moving on to the next matrix. The next matrix is, okay, before moving on, there is a simple exercise. Now, if you go through this exercise, so what's, you can see here it is mentioned as the output for threshold is 0.6. That means if it is greater than 0.6, it belongs to class 1. If it is less than 0.6, it belongs to class 0. Okay. So if this is your actual and this is your predicted, so this will be 0, this will be 1, this will be 1, this will be 1, this will be 0, this will be 0, this will be 0. Okay, because my threshold is 0.6. Now, considering this as your actual and this as your predicted, can you simply tell me I'm drawing the confusion matrix. Okay, I have my actual 0 1, predicted 0 1, right? So these are your true negatives, true positives, false negative, and false positive. Can somebody tell me how many true negatives do we have here? I'm waiting for your answer in the chat box. So just focus on these two columns, okay? This column and this column. How many true negatives do we have? One and two. So there are two true negatives. Okay. How many true positives? One true positive, two, that's it. Two true positives. Okay. Now, how many false negatives and how many false positives? I will wait. Just write down in the chat box FP this much, FN this much. Okay. So FP is falsely predicted as positive. That means actually it is 0, predicted as 1. 1, only 1, right? So FP is 1. And Fn is actually it is 1 but predicted as 0. So actually 1 and predicted 0 is one case and two case. So this becomes 2. Now if you go and check, yes, correct. Now comes the most important thing, which is recall and precision. Now how this formula is being fetched? These are the next metrics. Okay, so I'll go back to the Miro board and write it down. The next metrics are recall, precision, and F1 score. So try to remember this thing from your confusion matrix. I'm just taking a little bit up so that it is visible to you. Recall formula is very simple. True positives divided by true positives plus false positives. Precision formula is true positives divided by true positives. My bad, my bad. My bad. Recall is true positives plus false negatives. Okay, my bad. Precision is true positives divided by true positives plus false positive. And F1 score formula is 2 multiplied with precision multiplied with recall divided by precision per plus recall. Okay, now tell me, in this case, my TP is 2, my TN is 2, my FP is 1, and my FN is 2. So, what will be my recall? My recall will be TP divided by TP plus FN, right? Which will be 4, which will be 0.5. Correct? What will be precision? Precision will be TP divided by TP plus FP, right? Which will be 2 by 3. If you go back and check, recall is zero point 0.5 and precision is 2 by 3. Okay. Now, if I calculate what will be my F1 score, in this case, my P is 2 by 3, my R is 2 by 4 divided by 2 by 3 plus 2 by 4. In my numerator, it will be 2 into 2 into 2, let's say 2 to cancel. It will be 2 by 3 divided by, what will be the denominator? 12, 4 to 8 plus 2, 3, 6, which is 2 by 3 multiplied with 12 divided by 14. So if you divide 4, 2 with 7, this becomes 4 by 7, right? If I go back, 4 by 7. How can you remember all that? It's not that difficult. See, I will tell you how to remember. First, try to draw the confusion matrix. You don't have to memorize it, you will automatically understand. Just try to do this activity in 2 or 3 pages multiple times. If you do, automatically तुम्हारे दिमाग में आ जाएगा. Okay, so confusion matrix is actually versus predicted. Okay, 0 1 0 1. See, 0 is nothing but your uh, like in disease and non-diseased, 0 is non-diseased. In churned or not churned, 0 is churned, right? So imagine this as two negative, 0 is negative, 1 is positive, as simple as that. Now this box is actually 0, predicted 0, right? So truly predicted as negative. This box this box is actually 1, predicted 1, truly predicted as positives. This box actually 1 but predicted wrong, predicted as negative wrongly, so falsely predicted as negative. And this box is actually 0 but predicted wrongly as positive, so falsely predicted as positive. Now what is recall? Recall is uh, this divided by tp plus fn, this divided by this, and precision is this divided by this. And F1 score is simple, right? 2PR divided by P plus R. Okay? Nobody will ask you to remember the formula. Um, People will ask you about metrics, how to use them, and all those things, which I will teach you in practicals. Okay? So, this is one of the metrics. Going to the next one. Another metric is ROC curve. ROC curve is nothing but a curve where you can see in your x axis you have 1 minus specificity, and in your y axis you have sensitivity. Okay, now what is sensitivity formula? Sensitivity formula is tp by tp plus fn. So just write down these formulas in your notebooks. If you do it for 3 4 5 6 times, automatically you will remember these formulas. Okay, so what happens is when you draw a graph, let's say you are drawing a ROC curve. So this is your 1 minus specificity, this is your sensitivity. So let's say for this is for your model 1, let's say for decision tree. You have another one for, let's say, support vector machines, right? Now between these two, for support vector machines, this is your area under the ROC curve. We call it as AUROC, which is area under the ROC curve. So this is the area under the SVM, right? What is the area under DT? This whole, right? Whose area is larger? DT's area is larger, which means as per this graph, as per this curve, DT is a better algorithm than SVM. Okay, so this is basically your area under ROC curve. Got it? What is ROC? Uh, who knows what is ROC? What is ROC? Anybody knows? ROC is nothing but an operating characteristic. It is called as an operating characteristic curve. R is receiver operating characteristic curve. Okay. The main focus of this graph is, if you go back to your architecture, let's say I'll go back to the first architecture. Okay, let's say you are going through this entire flow, right? You have multiple models, dt, knn, rf, right? What we usually do is, we when we are doing an application, we are building a machine learning model, we basically do something like this. We create our Excel sheet. We will write it down classifier. Okay, and then we will write it down multiple matrices. Let's say what is the accuracy, what is the precision, what is the recall, what is the F1 score, what is the area under ROC, AU ROC, and so on. So let's say for KNN, then for decision tree, for random forest, and blah blah blah, right? So let's say KNN is 78, decision tree was 79, this is 88, precision let's say was 76, 74, and that's how you populate the entire graph. And then as a data scientist or as a lead data scientist, you take your call whether which algorithm is the best, and then take that model to perform the hyperparameter optimization. That is what we do. Okay, you cannot take a decision only based on accuracy, that random forest is the best. No, random forest could have a lower precision, it could have a lower recall, let's say 61, it could have a lower F1 score. So only accuracy is not important. Okay, so that's why we go through multiple ones. Another one is classification report. Okay, classification report is very important. I'll show you how classification report looks like. Panda, sorry, sklearn classification report. Yes, rectifier after operating curve, operating characteristics curve. So classification report looks like this. Okay, let's say you have two classes. Here we have three classes: class 0, class 1, and class 2. So for you will see something like this. This is a report card. For class 0, what is the precision, what is the recall, what is the F1 score? For class 1, what are the values? For class 2, what are the values? This is my personal favorite. I usually don't look at any other metrics because in classification report I can see everything. Okay, that's why usually go for classification report. Now, as we are winding up classification, I'll quickly go to the code, and for the support vector machines, I'll just show you how the classification matrix works. So from sklearn dot metrics, import confusion matrix. So let's say I will just print confusion matrix, and I will pass y test, and then I will pass my y pred. Confusion matrix will show something like this. That means what is the accuracy? The accuracy is this plus this divided by entire thing. So there are four wrong predictions. That's it. Okay, this is what confusion matrix is telling. But again, confusion matrix is not very clear, right? I mean, you can interpret the numbers, but personally speaking, I usually go for classification report. I'll show you what a classification report looks like. So this is how classification report looks like. Now, if you look at this graph, precision, recall, and F1 score for all the classes is showing me 97%, which is good. Okay. Another thing to notice is, let's say we will also do the classification report for a low performing model, let's say 93, 95, 99. Let's say I'll go for a 93 one, the knife base one. So let me just you change it to knife base, and here. So you can see in the knife base algorithm, we are seeing the numbers like this. Okay. So there is a strategy here to choose whether this model is better or that model is better. First of all, see, blindly, if you ask me, these numbers are far better, right? It is 97% throughout, right? 97% throughout. Here it is 94 and 92. So obviously SVM is a far better performing model. But apart from that, you should also consider this thing. Now in this case, if you go to your diagnosis column, you will see that the distribution is like this. So cancerous data is 212 records, which is how much percent? Around 37% cancerous patients, 62% non-cancerous. Okay. So what is your minority class here? Minority class is that class which is having less records. In this case, cancerous patient records are less, right? So if you ask me, what should I do? I will always go and compare these numbers with these. Now, as these are better, I'll go with this model. Okay. For me, honestly speaking, these numbers does not matter. I don't really give, I cannot say the word. I don't really bother about these numbers. Why? Because this is my majority class. I really don't care. Minority class is most important, because in industry level problem you will be working with very imbalanced data sets. Fraud detection is once in a million. If you are dealing with a fraud detection use case, out of 10 million records there could be only 10 or 12 frauds. So your minority class is very important. You should always check precision recall and F1 score for the minority class. Okay, that is the major thing. Got it? So there are some questions in the chat box. Why do we use recall and precision? Recall and precision are nothing but they are better metrics, right? Because they have been created in a they have been created mathematically. Their formula is in such a way that they form as a better better metrics to compare or to see. But theoretically speaking, if you say recall is nothing but uh, what is recall? Recall is nothing but how many correctly predicted, right? How many correct predictions divided by TP plus FN. What is TP plus FN? TP plus FN is actually true. So correct predictions divided by the actual um, actual positives, right? You can also call it as recall is nothing but the ability of a model to find all the relevant cases, right? All the correct predictions with respect to the actual positives. Similarly, what is precision? Precision is again correct predictions divided by TP plus FP, which is correctly predicted as positives. So predicted positives. These are just metrics, right? What is accuracy? Accuracy is Tn plus Tp divided by total, right? Correct predicted 0 0, correct predicted 1 1 divided by the total. That is your accuracy. No, 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 no. Recall, precision, and F1 numbers will not always be the same. It could be different. It has to be different, right? In the example also I showed you, right? It will be different. Recall and precision and F1 score is different, right? Sorry, this is not accuracy. uh, Accuracy is also 4 by 7 because it is 2 plus 2 by 7, but we have also calculated F1 score, right? F1 score was also 4 by 7. So recall, precision, and F1 score, they might or might not be same, not the case. Okay, so do not take it that way. And if you want to implement ROC AUC curve, again you can just explore sklearn AOC score is also there, or if you want to plot, there is also a plot for ROC curve. Okay, ROC AOC score will basically give you whichever model has the highest Let's say you are drawing, right? 1 minus specificity and sensitivity. Let's say this is your model 1, decision tree. Let's say the AUC score is 0.585, and you have another model, let's say SVM. Here the AUC score is zero point 0.6. Let's say you have another model, something like this. Its AOC score is like 0.89. So this becomes the best model as per ROC AUC. But as I told you, we should not take a final call only on one matrix. Rather, we should do it on multiple other metrics. Okay. So that's it. We'll quickly try to explain you about these things. Oh, the more I go through, the more topics I'm getting. And okay, let's take a very short break, 2 minutes break. Please be back after 2 minutes, and then we will cover these issues like for 5-10 minutes, and then we will jump into regression. Okay. In the meanwhile, whoever has not liked this stream, please go ahead and like this stream. Please like, share, and subscribe the channel as well. I'm assuming all of you have subscribed, else you wouldn't have been in this call. So please go ahead, like the stream. And after this video is done, after this class is done, tomorrow morning, you will receive the link again. Please go and comment out something, right? That's how the algorithms work. The more the likes, the more the comments are. Based on that, YouTube promotes the videos. Okay. So I'm trying my best to teach you everything for free. So the least that you can do is at least give me more engagement in the channel, likes and comments. Okay, go for breaks, 2 minutes break, and I will be back in 2 minutes, and then we will cover the next topics. Okay, I'm back. There is a very good question in the chat box, which is, uh, can we have multiple support vectors? So, for example, in practicals or in real scenarios, there could be thousands of data points, right? Understood. There could be millions of data points. Out of those million data points, there could be multiple points that are near to that line, right? Try to think, okay, because I cannot show you. um, in a problem statement, right, there could be multiple features, right? Let's say 50 features. Okay. Now, considering a 50 dimensional space, there cannot be two different data points in one location. If you have two data points in one location, that basically means all the features of the both the data points are same. If this is the case, then yes, there can be multiple points. But if this is not the case, all the data points, all the records are unique, they are all different from each other, then the chances of having multiple support vectors is almost negligible. It's very, it depends on the use case, but most likely it does not happen. But there could be a scenario, there could be multiple vectors, but it is very highly unlikely. You're able to get my point, because you are talking about multiple dimensions, right? So it is very rare to have multiple support vectors. SVM model is already predicting 97%. Why are we again calculating all these metrics? Uh, 97% accuracy, right? Or 97% recall and precision. This is a dummy use case. So do not consider this as your final project. This could be a good final project. This is a healthcare related use case. Um, in this use case, right now, if you ask me which algorithm is working the best, uh, right now there was KNN which is doing the best. If you go and check the classification report of KNN, you will potentially see, you, this is flawless, right? KNN is the best so far. So right now, if I have to take a call, KNN is my best algorithm. Do I need hyperparameter optimization? No, because it's almost 100%, right? The precision is 100%, the recall is 98%, which is fine. So I don't need hyperparameter optimization, but I can give it a try. So in this case, KNN is the best. So support vector machines is the second best, right? The reason why I'm calculating other matrices are just to show you. Okay. So you can potentially create a table like this. Pick a use case similar to this, maybe churn prediction use case or bank fraud detection use case, anything, and try to call multiple models and try to create a sheet like this. And then you can compare your results and take a final call. In case you create a sheet, you are confused which model should you actually consider as the best model, you can always reach out to me after the class is over WhatsApp or even on the YouTube video comment section, and I will let you know which model should you choose. Okay. So for now, moving on, I just have 5 minutes to cover this. In classification, there could be multiple problems. The first problem I want to discuss is class imbalance problem. Okay, before that, let me explain you what is overfitting. Overfitting is that kind of problem. Let's say, you have, um, okay, let's say you have a data set, okay, fraudulent records or diseased, non-diseased, anything. You are dividing the data into training and test. So let's say your training data is 800, your testing data is 200, right? Now imagine your model is being trained on the training data, right? After your model is being trained, let's say the model is giving you around 89% accuracy. After that, let's say Either you pass, let's say you pass a separate 100 records, new records. Now on these new records, let's say the model accuracy is around 45% or 50%, which means the model is working fine on your existing data, but on your new data the model deteriorates, model is not working. Why this problem is occurring? There could be multiple problems, multiple reasons. One of the classic reason is there could be a new pattern of data that is present here which was not present here or here, especially here, which was not a part of the training data. That's why the model does not know about this type of data. That's why the model is not able to predict. The prediction rate is low. So in this case where your training accuracy is high and your testing accuracy is low, you call it as a overfitting problem. That means model understands your existing data very well, but when you are passing new data, the model fails. That is called as overfitting problem. What is class imbalance problem? It's a very, very important problem. Okay, try to understand this thing. Okay, we'll take the example of, uh, let's say, cancerous and non-cancerous data, right? So let's say I have 1000 records, right? Out of 1000 records, my non-cancerous data is, let's say, 800. My cancerous data is around 200. So what is the ratio? The ratio is almost 80-20. Let's say you divide the data into training and testing. Let's say training records have 800 records, testing have 200. And if you divide it into equal ratio, here you will have 640 non-cancerous patients and 160 cancerous patients. Here you will have 160 non-cancerous and 40 cancerous, right? Can you realize that while training this data, the model has more information about the non-cancerous patients and less information about the cancerous patients? Why? Because non-cancerous data is more than cancerous. Okay, imagine you have a baby, right? You have a newborn baby or a baby with 5 6 months old, right? If you only teach the baby about cats, showing cat images, let's say you showed like 100 cat images and you taught the baby cats, cats, cat, this is a cat, this is a cat, this is a cat, will the baby be able to identify? If the baby spots a dog, will the baby be able to identify this as a dog? No, because you have not trained. Baby only knows cats. Let's say baby knows cats and dogs, only 10 records of dogs. Now will the baby able to identify dog properly? Still not properly. Will the baby be able to identify cats properly? Potentially yes, because baby already has so much information about cats, right? So what's happening here is, if you give this type of data, your model will learn less about your your cancerous patients. Now that is where the imbalance problem is. Now instead of this, let's say I will create a Python code. In this Python code I will write, for any patient, predict them as non-cancerous. So if I take these 200 records, 160 non-cancerous and 40 cancerous, this is my actual data, right? Y test data. What is my prediction? My prediction is a simple line. Everything is non-cancerous. So for 160, these are non-cancerous. For these 40 also, my model will predict as non-cancerous. These are correct predictions, right? So what will be the accuracy here? The accuracy here will be 160 by 200 into 100, which is 80%, which is treated as good in machine learning. 80% accuracy is good. Now, 80% accuracy I am able to get just by writing one line of code. So for any record, predict it as non-cancerous, which is wrong, right? Now, that's why we need to always balance out the data. How do we balance out the data? So there are two techniques of balancing out. One technique is called as upsampling. One technique is called as downsampling. Let's say, again, same example, you have 1000 records, you have, let's say, 800 training data and 200 testing data. Out of this 800, let's say 640 are non-cancerous, 160 are cancerous. Here 160 are non-cancerous, 40 are cancerous. Now here, as the data is imbalanced, how to balance it out? If you have to use the upsampling technique, what the model will do is it will keep the non-cancerous data as 640. It will manually duplicate and create replicas of your cancerous patients. Now it becomes balanced. Now you can build a machine learning model. Downsampling is you already have 640 and 160. You basically take 160 records from this, 160 records from this, and try to build another model. Let's say ML2. This is ML1. And then you compare which is performing good and then take your next call, right? So just try to write down the libraries in case you want to try it out. Resample is there for doing upsampling and downsampling. We have smart, we have smart ENN, we have Adasyn. So these are some of the libraries that you can check and do the this part, solving part. Now in case you are interested in oh wait 1 second, I might have a video on this. If yes, that will be the best thing. I actually don't remember if I have a video on this. I wish I can teach this, but unfortunately I might not have bandwidth to teach this. Unlocking the future full potential of random forest. Ensemble methods are there. Let me search if I have. Um, um, smart. I don't remember if I have. Oh, I have. I have a video. Just search like this, okay? Smart Satyajit. I'm not that famous, so you have to write my name if you want to find my video. So there is a video, you can watch it out, and if you have doubts, then only you tell me. In one of our next classes I will cover this, okay? For now I'm not covering because I'm out of time. Okay, so that basically brings to an end to classification. Okay, so now we will be jumping into regression part. When it comes to regression, first of all, try to understand what exactly is regression. Regression analysis is nothing but a form of predictive modeling technique which investigates the relationship between a dependent, which is a target variable, and an independent variable. This technique is used for forecasting, time series modeling, and finding the causal effect relationship between the variables. Again, boring theoretical lecture. I will directly jump into my Miro board and try to explain you about regression. very bad handwriting. Okay, a fun question. How many of you think I'm using this thing to write down these things? We have a digital pad, right? Usually, all the teachers use digital pad to write down these things. Do you think I'm using a digital pad or I'm just using a mouse? What do you think? I'll answer your question, Bashir. Good question. I'm using a digital pad. My handwriting is found fine, right? Many of you might be a little bit shocked. Mm, I don't use a digital pad. There is something that you might not know about me as well. I was I have played. I have actually I was a gamer. I come from a gaming background. I used to be a gamer. I have represented. I have played the state level things in some of the computer games long back when I was in college days. I have a bunch of like 50 plus certificates. I have, so I'm very good with my mouse. So I use mouse. I don't use a digital pad. Coming back to your question, Bashir, how to solve the overfitting problem, right? So overfitting problem is solved by multiple things. Balancing out to certain extent can help you to sort out the overfitting problem. Sometimes what happens is in your training data, you might have some information. In your testing data, there could be new type of information. If you are having a problem in that, let's say your training accuracy is fine but your testing accuracy is low, your model is not able to do a good accuracy or good performance on testing data, then in that case you need to shuffle the data. There are different ways of shuffling. While shuffling, what happens is some of the testing records goes into training part, right? And then you have to retry the mechanism. Internally, pandas also provides you the shuffle mechanism. You can shuffle your data. Okay, so that is also another way. um 1 second, there is some comment in the comment box. Okay. Some other mechanisms are also there. That's what I told you. Machine learning is a very, very deep topic. And that is why my 12 hours lectures are enough. But there could be new things which might come to your mind, right? So 12 hours might not be an end to end on machine learning. I'll be very honest with you. I will try to explain you as much as possible, but there will be certain things which you will not be able to understand even in this 12 hours lecture. So for example, from here we might have to go into a direction where you're asking about overfitting, right? Overfitting can be itself, I can teach about overfitting for like 5 to 6 hours. There is a technique called as cross validation which we use. There are some feature selection techniques that also we use to get rid of overfitting. So for example, let's say you have a data set, okay? Now I'm telling you theoretically, practically it's not possible for me to go through that. But in my end-to-end AI course, I have explained everything in depth. So just I'm answering you so that you can handle it in your interviews. Okay. Now let's say you have 50 features. Okay. You have a overfitting problem. That could be because of a reason why you have some information here which is not present here, right? So the first solution could be shuffling the data. Can shuffling help? To certain extent it might help, I don't know. Okay, but we should always give it a try. Another technique is obviously increasing the data. That is a very, very basic answer that you can give to the interviewer. Increasing the data. Obviously, if you increase the data, there could be a scenario where overfitting problem is solved. Another important thing is cross validation. This is the most important thing. It is somehow related to shuffling, but it is not exactly shuffling. Cross validation basically, it involves converting the data into different subsets. So let's say you have your data like this. Let's say you make this as your training, this as your testing. In the next split, you make this as your training, this as your testing. In the next thing, you make this as your training, this as your training, this as your testing, and something like this. You do it with multiple steps, and then identify the best one. So that is also another technique. Another important technique is feature selection. So let's say you have a data, you have 50 features. Are all these 50 features important? No, right? Definitely there will be certain features which are not important. There will be certain features which is unnecessarily using in the model, because of which the model is not performing well. So if you perform feature selection processes, and let's say you are able to cut down to, let's say, 20 features, there could be a scenario where your accuracy, recall, precision, everything is getting more as compared to the original model. So you eventually might solve your overfitting problem. Okay. Another another solution is ensemble methods. Okay. Ensemble methods can also be used to get rid of overfitting problems. So you can give different answers to your interviewers, whoever is asking these questions. Okay. So that's how it is. Now, how to tackle all these things? Cross validation, um, this is an important thing, but again, lack of time, so I'll not be able to cover. So I'm jumping back to regression. Okay. In case you have any questions, keep it handy, or just post it in the comment section, in the live chat. I will go through them after my regression is complete. Today we will not be able to do the practicals of regression, so obviously we'll stick to the theoretical part of regression, and eventually we will go through the practicals tomorrow, and then immediately we will jump into clustering. Tomorrow um, is the fourth class, and then we have two more classes. So in fact we have three more classes. So tomorrow is another class, 28th, then third and fourth. After that, um, 10th and 11th July onwards, I will not be available for 2 3 weeks because I'm traveling. But once I'm back, probably in September, I will again resume my live classes for deep learning and generative AI. Okay. So good news for you, but bad news for me is I'm not getting enough viewers. You can see first class we had 50 students, second class we had 30, now we have 15. Anyways, coming back to regression. So regression is, there are multiple types of regressions. Okay. The first simple regression is, the simplest algorithm is simple linear regression. Okay. Which is called as SLR. The second one is obviously multiple linear regression, which is called as MLR. We also have polynomial regressors. Okay. And various others. All the algorithms that you have studied so far, decision tree, random forest, all of them also have their respected regressors. Okay. So but we will be majorly focusing on these. I will try to talk about one of the regressors just from the coding point of view. but majorly we'll be focusing on simple linear and multiple linear regression. Okay, what is simple linear regression? Simple linear regression is just a hypothetical scenario that never exists. Okay, so a simple example of a simple linear regression is, let's say I'm talking about house price prediction. House price prediction. Let's say you have a feature called as area and you have a column called as price. So for 500 square feet, the price is, let's say, uh, 30 lakhs. For 600 square feet, the price is 40 lakhs. For 1200 square feet, the price is 90 lakhs. For 1600 square feet, the price is around 1.5 CR. So you can write it down as 150 lakhs. Okay. What will be the price if the area is 700 square feet? That is the question. Okay. What you need to predict? You need to predict price. So this becomes my y variable. This becomes your x variable. Okay. Because area is your independent feature. Price is your dependent feature. Okay. Um, just one second. So price is your dependent feature. So based on area, you will be predicting the price. Okay. So if you draw this graph, let's say price, let's say area on my x axis and price on my y axis. Okay. Let's say I will draw some data points here. Let's say uh, 1 2 3 4 5. So this is, let's say, 500, 6 7 8 9 10. This is 1000, 11 12 13 14 15 16. This is 1600. So price is, let's say, 10 20 30 40 50 60 70 80 90 100. 120 30. Just give me 1 second. Just give me 1 second. Okay, sorry. So if I draw these data points, right, area is 530. So 530 is somewhere around here. Second is 640. 640 is somewhere around here. Third is 1290. 1290 is 40, 50, 60, 70, 80, 90. So somewhere around here, right? 1600 150. 1600 150 is, let's say, somewhere around here. Okay. Somehow it is very linear, straight line. Let's say we'll take change this to, let's say, 100L. 100L. Okay. So let's say 100L is somewhere around here. Okay. Now these are the four data points. Now what we need to do is, SLR tells you to find the best fit line. Okay. So some of the concepts that we studied in SVM will also be used here. Okay. It needs to find the best fit line. How many lines can we draw? I can draw multiple lines, right? Line 1, line 2, line 3, line 4, line 5, line 6, line 7, multiple lines. Millions and millions of lines are possible, right? So for the sake of your understanding, I'm just drawing two lines. Okay. This is line 1, this is line 2. Similarly, there are multiple lines. So from line 1 till line n, right? What we need to do is, we need to find which line is the closest to the data points. How do we find? we need to find the distance of these data points to each of these lines. Let's say this data point falls on L1, so this distance is 0, right? This is one distance, this is one distance, and this is another distance, right? So imagine your total distance of line 1 combining this and this, let's say, is 5 units, for example. What will be the distance of these data points to L2? This, 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 and this, right? So combining this, and this, let's say I will write it down as D2. Let's say this is of 15 units. Obviously, D2 is larger, right? Because it is far away. Now, as L1 has the lowest units, let's say similarly, we will do it for multiple lines till Dn. Imagine this is the lowest. So L1 becomes your best fit line. Okay. So I will redraw this. We have one data point, two data point, three data point, four data point. So this becomes my best fit line. Okay. Now the question is, what will be the price at 700? So what you need to do is, on top of this best fit line, you just need to project 500, 600, 700. Just try to project straight line, and whatever value you see on the y axis, that becomes the prediction. So in this case, the prediction will be somewhere around 52 lakhs, right? How these distances are calculated, how to calculate distance? If you have a data point 2 comma 3 and another data point 8 comma 6, a and b, what will be the distance formula? Remember this thing, ab is x1 minus x2 square plus y1 minus y2 square root over. In this case, it will be 2 minus 8 square, which is 36, plus 3 minus 6 square, which is 9, root over. So 45 root over is somewhere around 6.7, right? So that is your simple linear regression. Now, what will be the formula of this line? The formula of this line is y is equals to mx plus c. Okay. Can I write it like this? Y is equals to m1 x1 plus c. Yes, I can write it down because there is only one x here, which is x1, and this is my slope, this is my intercept. Again, coming back to this use case, house price prediction. Is this actually possible? No, right? House prices do not only depend on the area, right? It also depends on the number of bedrooms, also depends on number of bathrooms, also depends on the distance of the nearest market, distance of the nearest hospital, distance of the nearest railway station, distance to the airport, whether it is under urban area or the rural area. So hundreds and hundreds of features are actually impacting the price. There is not just one feature, right? Now in this case, if you have hundreds of features, can I write it like this? For hundreds of features, my y will be m1 x1 plus m2 x2 plus m3 x3 plus dot 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 mn xn. In this case, your n could be 100, m100 x100, but I'm just generalizing this formula. This is going to be your formula. If you have more features, this is nothing but multiple linear regression problem. Okay, cool. That's it. Regression is over. Understood? Polynomial regression will be covering tomorrow. So we will wind up the class here itself. Tomorrow we will be so we will have this agenda. Okay, we will try to follow the agenda. Let's try to give let me try to give 3 days agenda so that you all are aware of the classes. Okay, so tomorrow's agenda, I will write it down as 28/7. Tomorrow's agenda is regression, covering the polynomial and one more regression and the practicals. Practicals are very important, so do join the class on time. Next, we will be jumping into clustering. Clustering, I will be taking a very good use case, so please be there. I will also try to talk about a combination of clustering plus classification problem. Okay, and this is a real time problem I'll talk about. Okay, so this is the agenda for the tomorrow's class. 3rd July, 3rd August, we will plan to have, so after clustering is over, we will plan to have time series analysis and forecasting. So we'll try to go through some libraries like Arima, Facebook Prophet. If I have time, I will cover LSTMs. If not, I will not. Um, this is a very good class. In fact, one of the most important classes. And then on 4th of August, we will plan to have hyperparameter optimization. I should be able to finish it in 30 to 40 minutes. Um, if you are not able to understand my PCA videos, please go through the PCA videos in the playlist. If you are not able to understand, I might cover PCA, PCA and LDA, and then last 30 minutes we will try to take a project. uh, this last class potentially will be a 3 hours class because I will not be able to finish it in 2 hours. So this will be 2 hours, this will be 2 hours, this will be 3 hours, and overall it's like 13 hours. I think we are good. uh, 80 to 90% machine learning is over if you are able to attend all the classes. To complete 100% is impossible. Even I have not completed 100% because this field is too depth, it's too deep. It's like an ocean. Every day you will learn something, right? So even if I am not at 100% level, I might call myself like 95%, but with all these classes you will be at 80%. And then if you have some questions, you can ask me in the groups, and you can ask me in all the communities that you are part of or over LinkedIn, and then I will be able to answer it. Okay, and going forward we'll have deep learning and other classes. So now let's try to, okay, there is a question for my course. However, I have not pitched my course today, so it's good thing that somebody is asking about my course. Let me talk about my course. Okay, many people, I forward this link to many people. People don't go through this syllabus properly, and then they come back and ask me hundreds and hundreds of questions. Whoever is interested, please ping me on WhatsApp, LinkedIn, or anywhere. I will send you this syllabus link. Syllabus link is also there in the description. Please spend some time to go through these features. Okay, this is a pre-recorded content, which means I have dedicatedly sat, recorded all the videos. If you want to see, um, I have machine learning videos for around 22 hours is mentioned in the folder, but there are 25 to 26 hours of contents. We have intro, prerequisite, regression. So you can see regression, we have multiple things like lassos and ridge regression as well. Classification is there, ensemble, clustering, association, feature engineering, Everything is there. When it comes to NLP, again, 9 hours is in the folder, but there are more contents. Transformers and generative AI is there. uh, Lot of projects are there. The best thing about the program is I am there to support you. If you go to any other program, I really don't mind. You go and take any other program, I literally have no problem. Because if you are spending more money, I mean, why would I be worried about it, right? Many people usually go for simply learn and edureka, 80,000, 1 lakh, 1.5 lakhs. There is no need of spending money. There is no need. They will only teach you the classes, and then after the classes are over, they will not help you with your doubt clearing. As simple as that. If you don't believe me, you just go experience yourself. In that process, your money is gone, your 6 months time is also gone. In my program, it's very simple. Everything is pre-recorded, and you all know my way of teaching, so you are familiar with the trainer, right? And the most important thing is guidance. Whenever you are stuck in your journey, you have any questions related to any complex topic, I give the privilege to all of my students to ping me personally. Whoever is not a part of my program, they still ping me on WhatsApp. I still answer them as part of a good gesture. But for my students, my paid students, I always respond on time. There are dedicated communities, internal communities only for the students, where I help them. I help them with queries, I help them with resume preparation, I help them with interview preparation. Whenever I have an opening, I send it to the group as well. Those kind of support I give. Coming back to the curriculum, there is a in-depth curriculum. Please go through this. I don't want to spend a lot of time explaining in this video, but trust me, after this curriculum is over, you don't need anything. You are good. I have Python, Stat, SQL, Excel, Power BI, Tableau. Data analytics is also there inside data science and AI. Machine learning, NLP, deep learning, generative AI, transformers, projects, everything is there. Okay. So yeah, it will be something like this. So if you go to my platform, once you are a paid student, you will be visiting the my courses. Here you will see the AI course. I have enrolled for a lot of courses for testing purpose. You will be able to access the AI course in the join our community. I cannot show you, but yeah, there is a link for an internal WhatsApp group, and then you'll just have to follow these modules. After every module, right now there are no quizzes, but I'm going to add them, and I'm also adding more and more projects in the program. Time series course, you want to see my time series videos? My time series course is already there on Udemy, just in case you want a budget friendly time series course. But time series is also part of my AI program. I have time series, 10 hours of content on time series only. Time series was my first research work. So in time series analysis and forecasting, I can challenge any experts, like any researchers as well, because I'm it's like in Hindi we say, right, goal ke pee ke hu, something like that. So time series analysis and forecasting, I'm proudly, I can say myself a pro. Time series and deep learning and generative AI. Generative AI is a new field, right? So uh, it's a it's a new area. I'm still learning. I'm not at the expert level, but I'm at that level where I can build products. I have also built generative AI products, but on time series analysis and on deep learning, I have multiple research papers. Okay. Going back to the comment section, let me just stop my share. Um, Going back to the comment section. So Okay, if you have any ask questions, you can ask me. Okay, I'm going through the comment section. So it will be. I was completed the first part, and this was explained very well. Thank you. Okay, good. I'm going one by one, guys. So please give me some time. Sir, which one has larger distance, then it is better, right? Yes. Larger margin, the better the line will be. Huge data, how do we know if the data is balanced? I think I answered this. You have to just find the class distribution of your y variable. Let me go back to StreamYard from here. Actually, I'm doing multiple this thing, right? So that's why. So let me go through the comments here. Um, why does the recall precision F1 signify? I think I already answered this. Recall precision and F1 score, they have their own significance, and especially you have to take care. You have to watch these numbers for your minority class. They do not have same numbers all the time. So I think I already answered this. Bashir, I think also I have answered this question while explaining. So I'll skip this part. Thank you, Vikram. Solution for overfitting is also covered. Thanks, Bashir, for asking really good questions, because actually these are interview questions which interviewers ask you, and and it is, you should only answer based on your personal experience. So once you study everything, go and practice. While practicing, whatever you get the problems, how are you getting out of that situation? Based on that, you can answer. But I have already given you a dummy answer, right? You can go through that. Yes, one independent and one dependent feature is called as SLR. Yes. Thank you, Sonu. I'm learning from open source. I know what valuable. Okay, no problem. As I told you, I don't force, right? Enough contents are already there on the internet. If you, and now we have Chat GPT also, so you can use ChatGPT as your tutor as well, so you don't have to pay anything. But not everybody is same, right? Some people need mentoring, some people need motivation, some people need somebody should be there with them all the time. Only for them they can actually take the course, or else it's fine. Thank you. Shiva, I think I covered that part. My course part is already covered. So, do you have to calculate information gain of the features to decide which feature is going to be the root node before applying criterion? Um, Mathematically, we don't do. Practically, how do we choose criterion? I have explained you that it's a hit and trial, right? You try with different criterion, see how your model behaves, and then based on that you can take a call which criterion is good. Mathematically, how the Gini and entropy is calculated, I have covered, right? um Thank you, Neeraj. Wow, good comment, thank you. Can you repeat the definition once more? Which one? If Sweta, you have another question, or maybe you can clarify this question, you can just repeat. I'm not sure which topic you want. Need time series course. Okay. Time series course link. Maybe I will give it in the description. You can check it out. Like a website where we will learn from. Yeah. Total number of. Okay. That's okay. So this AI program is of 140 plus hours. Okay. So 5 to 6 months will be needed, but if you're interested, get in touch with me on WhatsApp. I will separately talk to you rather than talking here, so I can give you more insights, and I'll help you understand more about the course. Okay. I don't want to do a very elongated public speech on my course. So if you're interested, you reach out to me. As simple as that. Um, Please share the time series video link and its coupon as you had mentioned. Yeah. So we'll do that after the time series video is over. Once we teach time series, I'll have to see how much I'm able to cover, how much I'm not able to cover, and then based on that, I will give you. Okay. Could you please do a video on what are the problems a beginner and intermediate level data science? Yeah, this is a very good thing, Bashir. The way I have top interview questions, scenario based and non scenario based for Power BI, I am coming up with separate videos for machine learning, generative AI, Tableau, SQL, and many more topics. So just stay connected, and I'll tell you, because in machine learning and AI and these kind of things, it's completely scenario based, which means based on what you know, the interview will proceed. If you know time series analysis, if your resume is shortlisted, they will grind you on time series. What have you done? What algorithms have you used, and so on, right? So it completely depends on your profile, but somehow I'll come up with videos on that so you can watch it out later. Or else if you want to have kind of a dedicated one-to-one call with me, based on your resume, what all interview questions are expected, that I can give you, but that will be a paid call. So on TopMate, I can give you the TopMate link and you can reach out to me. Okay, so that's it, guys. Thank you all for joining this class. Uh, Finally, we have completed the session 3, class 3. Tomorrow, we will be joining same time for class 4. And thanks all for joining. And hope to see a better numbers tomorrow. Please try to forward these class links to your college groups, to your friends. If you are able to do some LinkedIn posts by tagging me, please do that, because free classes are being conducted, 10 to 15 people are joining, which is very very depressing for me. I'm not pretty sure whether I'll continue after ML is over or not. I'll be very honest, because a lot of time is gone, and I also work on freelancing projects, right? So I feel like I would have given more time to freelancing rather than coming live. But yeah, anyways, as I have committed, at least some of you are very serious, so for just some of you, I'll complete the machine learning thing for the next two more weekends, like tomorrow and the next weekend. But after that, whether I'll continue with deep learning or NLP, I am not 100% sure. So see if you're able to spread the word among others. That will be of great help. That's it. Thank you. See you tomorrow. Bye bye.